Hello, my name is Tarek, and today our topic of discussion is stack data structure. Stack is a simple but very powerful data structure. It has been used in different areas of computer sciences, and we will see its implementation and its usage in the subsequent videos, the later videos. In this lecture, we will focus on its arrangement, how this data structure works, and what implementation strategies we can implement, we can use to implement this data structure. So as you can see here, we have a stack of book and stack of tires and a stack of clothes. As you can see the arrangement of these three different objects, then the objects are being placed on top of other. As you can see in the case of tire, the first tire is at the bottom, then on the top of first we have the second one, on top of second we have third, and on top of third we have fourth. And same arrangement is here with the clothed object. So the stack is the arrangement, or you can say stack is a data structure which works on the principle of LIFO, last in first out. Whatever element we have placed in the last, that we will taken out first. For example, if I want to remove this second tire from this stack of tires, so what would be the procedure? I will first have to remove the fourth one, the top one, then I'll remove the third one, and then I can access, or then I can get the second tire. So this is this stack data structure. So the stack data structure works in last in first out format, and it holds all the objects of same type. Usually it holds all the objects of same type. So a stack is a linear list of items in which all additions and deletion are restricted to one end. As you can see here, this is an empty stack, then we are putting 1 in this empty stack. Then here we have 1, then we are putting in the second element. And if you want to pop out or remove the elements, so the last element that we have put in will be popped out first. Okay, the operations of stack, if we discuss about the operation of stack, we have push operation to insert the element, pop operation to remove the element, is empty, is full, is empty, is to check is the stack is empty or not, and is full is to check is it full or not. You can implement other methods also, but I have, just for the sake of simplicity and just for to give you an idea, I have written only 4 methods. So as you can see here, we have an array, right? We have an array of size 6, and initially this array is empty, and we are pushing the data one by one. So we are pushing a into this array. This array, we have just to give you an idea that we are implementing a stack using array data structure. So we are pushing the first element into this stack. I'll call this stack instead of array. So we are pushing a in this stack. So here we have a, then we are pushing b, c, d, e, and f, and all the elements we have pushed in that are arranged in this order. Now the stack is full. If in this filled up stack, if I want to insert a new element which cannot be hold because there is no space to hold the next the new element, so what can happen? Here as you see, I am trying to push G in this stack, but the stack will raise an error and will say stack overflow, that you are trying to insert more element but I don't have space to hold that. So in that case, in stack overflow, exception will be raised. Now if I am popping the element out, so what I am doing is, when I'll call pop, the last element will be popped out first. As you can see, the f has been removed, and the total size is now 5. Now I'm calling pop all one after another, and I've popped all the elements. Now I've removed all the elements from this array or from this stack. Now if I want to pop again, but if and as you know the stack is empty now, so in that case we can get the stack underflow exception. So we have two kind of exceptions: stack overflow and stack underflow. If the stack is full, if I want to insert more elements into it, I will get stack overflow exception. And if the stack is empty and I'm trying to pop the elements again, then I'll get stack underflow exception. So now let's discuss the implementation strategies. How can we implement this stack as we have been doing it in our previous data structures, that we are not using any predefined or any language given class. We are implementing data structures on our own. So let's discuss how can we implement this stack data structure and what can be done. So first option we have is array. Using array we can implement the stack data structure easily, but we have few constraints, we have few boundaries that we need to take care of. The first one is size constraint, because array is a fixed size. So if we are trying or we will implement a stack using the array data structure, we need to take care of the size. It can happen that uh, uh, our stack can become full, and then if we will insert more elements, then we can get a stack overflow exception. So for that we will need to take care of this problem, and with that we need to create a new array and copy all the elements when the array fills up. So this is the one of a drawback of using, you can say, a drawback of using array. So what other options we have? We have linked list also, right? In the linked list, as you know, there is no problem of size because it can grow dynamically. So how can we use the linked list and how we can implement this stack using the linked list? Suppose this is the first element of the stack, and remember, stack works on the last in first out strategy. This is the this is how this stack works. So if I want to insert the second one, then let me copy it and let me call it let's say this is data 1 and we are inserting data 2, or this is the head node, right? So what we will do is we will insert the new element and we will point, what we will do, we will point the new element, or we will reference the new element to the previous one, and then we will change the head node to the latest element that we have inserted, right? Now as you can see, if I want to remove an element, if I want to pop out the element, so we can remove the head element and then we can change the head position to point to the next one, right? This is how we can implement the stack data structure using linked list. Suppose if I want to insert another one, let's see. So here we have data 3, right? Data 3, right? And let's copy this arrow and point this to the second one, and we will update the head node. Now the head node is not the second one, the head node is third one, right? And this is how we can implement stack using linked list. So the what will be the advantage? The advantage that we will have here is we do not need to take care of the size. We will not be worrying about size anymore, because there is no uh, initialization size we need to give to the linked list. Linked list works dynamically. We create references to the elements, and this is how the linked list works. So this strategy is more appropriate than using arrays.